So this video is now going to look at 8E, which is on geometric sequences. If we recall, arithmetic sequences are found when each term is made by adding or subtracting the same number. And we called that same number the common difference, which we use the pronumeral D to represent. A geometric sequence, you might remember I had mentioned this word before, and this is when each new term is made by multiplying the previous term by a fixed number, which is called the common ratio, and we give this a lowercase r. So the common ratio r is found by taking any term and dividing it by the previous term. So some will be the second term divided by the first, or the third term divided by the second. And what we want to find from that is that each time we keep getting the same number coming out, so that same r ratio. So if we look at this first sequence here and we want to try and find r, if we take t2 over t1, that means 12 over 4, and 12 divided by 4 gives us 3. If we look again at t3 over t2, so that would be 36 over 12, and 36 is divisible by 12 3 times. And if we do the last one as well, so t4 over t3, that's saying 108 divisible by 36, and that also gives us 3. So what we're saying here is the common ratio is 3, so we're multiplying by 3 each time to get the next term of the sequence. So if we look down here, then question 1, it wants us to say which of the following is a geometric sequence. Now remember, geometric sequence, we're multiplying by the same number over and over and over. So if we look at A here, if we do T2 over T1, that's saying 60 over 20. And hopefully you agree with me that 60 goes into 120 and it becomes a half like that. If I do the same thing, T3 over T2, and I've got 30 over 60, they're both divisible by 30. 30 goes into 30 once, into 60 twice. So again, I've got an R value of a half there. And if I check the final pair, T4 over T3, I get 15 over 30. And again, I get a half. So it doesn't always need to be that we're multiplying by a whole number. We can multiply by a half, which is the same as saying, I guess, divided by 2 the whole time. But in this case, r equals a half, so this is geometric. If we look over at B here, we can check this again. So if we do T1 over T2, that's saying 6 over 3, and that becomes 2 for us. If we look at the next pair, so T3 over T2, that's 18 over 6. That actually becomes 3. And if we check the last one, just to be sure, we get 36 over 18, and that simplifies to be 2. So what we can see here is to get from 3 to 6, we've times by 2, but 6 to 18, we've times by 3. And because we're not multiplying by the same number, we don't have a common ratio, we don't have an R value. So this is not a geometric sequence. So we don't have a clear pattern taking place here. We also, with arithmetic sequences, spoke about graphing them. Now, when we graphed arithmetic sequences, they had straight line graphs because we were constantly adding or subtracting the same amount over and over. Geometric sequences, however, will have a curved graph, and so they will be increasing or curving upwards when r is greater than 1. So when we have an r value that's larger than 1, up. It'll start to curve down if r is less than 1, if it's between 0 and 1, because that means we're timesing it by a half, so we're shrinking the number down each time. So it says here to create a table of values from 1a and then plot a graph of the values and describe the graph. So if we put here n and tn, we had 4 terms, so 1, 2, 3, 4. We started at 120, so 120, 60, 30, 15. Now, if I graph these, I've got n here, I've got tn up here, and this is 1, 2, 3, 4. 120, half of that is 60, half of that is 30, half of that is 15. I'll put in these extra lines. And if I plot this now, at 1 I'm at 120, at 2 I'm at 60, at 3 I'm at 30, at 4 I'm at 15. And you can see quite clearly straight away that they are curving, and if I join them up, I also see that curve shape more. So if I describe the graph, we can see that it is decreasing and curving downwards, okay? Hence, my R value is between 0 and 1, which we knew that because we actually already knew that R was a half. So I knew then the numbers were shrinking each time. So that there is a little introduction to a geometric sequence. Remember, geometric sequences, we are checking that common ratio aspect. So you will have to check the ratio between each terms just to make sure that they are all increasing or decreasing by the same ratio.